What's poppin', dogs? Mr. Allen here. We got some dope arc length action going on here. I'm excited. I'm pumped. All right, if an arc length is 16 meters and the radius is 3.5 meters, find theta in degrees and in radians. Now, we can figure out in one of them and just convert it, but I'm thinking I'm going to show you guys both ways of how to do this because usually on a test, they just ask for it in degrees or they would just ask for it in radians. So no need to do the conversions there, all right? We're just going to do both of them as separate problems. First off, we'll do the degrees. Now, I personally like to write this out as a proportion where I have my arc length S over my circumference, which is 2 pi r, is equal to my angle theta over, what's the total number of degrees in a circle? 360, okay? Some people will write it where they have S equals this guy times the 2 pi r. They just multiplied it over to have an arc length equals formula. I like the proportion because sometimes they ask for theta, sometimes they ask for r, just depends. And sometimes they ask for the arc length. In this one, we're asking for theta. So I'm just going to plug in everything that I know here, and then we'll cross multiply and solve this thing. So my arc length is 16. Let's see here. My radius is 3.5, so 2 pi times 3.5. And then I've got theta that I don't know. That's what I want to figure out over 360. So if I cross multiply and solve, 16 times 360, I don't know what that is, but we'll do it in a sec. So 360 equals, and then we've got theta times 2 pi times 3.5. So I'm going to divide by that 2 pi times 3.5, 2 pi times 3.5, and we got 2 pi times 3.5. That's gone, and when I plug this all into my calculator, my handy-dandy TI, I'm going to go ahead and just have my answer, right? So let's go ahead and hit alpha y equals to set up a fraction here. It'll be easier to type it in. So I got 16 times 360, go to my denominator, 2 times pi times 3.5. You could have also just used parentheses, but when you do that, make sure you have parentheses around your whole numerator, these guys right here, divided by, and then parentheses around these two right here, because otherwise it'll do division. It might screw some things up, so be very careful with it, all right? And I get 261.92. 261.923, so 0.92 degrees. That is my answer in degrees. We done with that half of the problem. Now, again, we could have just converted that. Actually, let's do that. And then let's see if we get the same answer, right? So I'm going to multiply this guy by pi over 180. So times, parentheses, pi over 180. And I get 4 points. So let's remember this here. I'll throw it in a different color. We get 4.57 for my radians here. Let's see if we get the same thing. Good way to check it, right? All right. Now I'll go ahead and work in orange. You know what? I'm gonna go pink. Okay. So let's see here. Different formula here. All right. S equals r theta. That's a pretty common one. S equals r theta. No need for a proportion here because really you can just easily solve for any one of those variables by dividing by the other one that you don't know, right? Or the one that you do know. Alrighty, so what do I know? I know that my arc length is 16. My radius is 3.5. And as we said, it's pretty easy to solve in this one regardless of which stuff you know and what you don't. I'm just going to divide by 3.5. And I'm thinking right now that 4.57 is looking pretty good because 16 divided by 4 is 4. And we're dividing by something small, we get something bigger. All right, so 16 divided by 3.5, and I end up with 4.57. And the exact same thing, man. That's dope. So we learned how to convert here, right? I multiplied by pi over 180. And if I want to go back the other way, I multiply by 180 over pi, and we get back to that 261.92. That's dope. Degrees, radians, America. See you later.